Good evening or good afternoon. Um, so my name is Antonio Almeida. I'm here to talk about IoT related topics. Does anyone here has work on IoT or has IoT projects? No? Okay. So I hope you find this interesting. So the approach, the concept behind this presentation is there was this idea like 10 years ago about making the web smart and making ways so that machines, when they talk to machines, a server to a server or a client to a server, they could understand what is the content of the messages they are exchanging. And understanding here means understanding the context, understanding the meaning. And that's why it's called semantic web. You want to have the meaning about what's being exchanged between this client and the servers or between servers. So the idea there was to make the web more helpful for humans so that the machines would assist the humans better. So there was a lot of ideas. One was to develop agents where you would send an agent that will do a search for you, and since the search results will be returned, will be semantically marked, your agent will be able to tell you exactly if that what you were looking for was there in the search results or not. So I'm going to start with this story of the semantic web. So this was in 2005. It was Tim Berners-Lee, the creator of the World Wide Web, that introduced this idea. And the idea was, like I said, to make the machine smart and to make machine-to-machine communication be more useful for you, so that instead of you, when you do a search, do a search on Google or whatever other search engine you use, you have to interpret the results yourself. So you cannot do a search using an agent or a program, because the program either it has to do some sort of text analysis or natural language processing, which is kind of heavy, or it does not give you any additional information. It's up to you to do the interpretation and to understand the meaning of what it's given in those search results. So this was a big process, and the idea was to make possible for the machines to reason about the messages they are changing. So this was one of Tim Berners-Lee's quotes. He said the semantic web is not a separate extension of the web, but would be part of the web, and it would evolve on top of the existing web. So this was based in a concept from artificial intelligence from the 70s, from Marvin Minsky from MIT. It's called frames. And what you do is you represent the knowledge in terms of an hierarchy. And then you derive, from this hierarchy, you derive the meanings to properties and predicates. I'll show you an example. So, but the question is that this would imply that all the web pages that are out there would have to be marked up so that now you could explain or define the page in terms of these ontologies defined by the frames. So we have here an animal, okay, a lion. You know that is a carnivore, right? You know that is a carnivore. It is an animal that eats an herbivore, okay? And an antelope is an herbivore. So basically what this does, so it says here, is that the antelope is an herbivore that eats plants, and a lion is a carnivore that eats antelopes, okay? That's what he's saying here. So the idea was to have a structure like this around all web pages. Then once you define these relationships between the several parts of the information of the message or of the message being exchanged, you can understand what's going on because everything is marked up. But of course, see, you would have to mark up the pages, and there were multiple standards for this. And the most popular was one around XML, and they defined this thing which they called the OWL, which was Web Ontology Language. It should be WOL, but they thought it would be funny to call it all because then we'd have an association with an owl, which is an animal that's supposed, a bird that is supposed to have an association with wisdom. So you would have to mark up all your pages. If you have a page about lions, you would have to mark up your pages and say exactly what is a lion. And there would be an ontology for lions, for animals, and would be for carnivores, and would be an ontology for herbivores, and would be, you can extend this. You can use all the taxonomy of the animal world if you want, and you will build this taxonomy, and you have to mark up your page according to it. And then if you have another machine or a client that understands how to process this ontology and this markup, then this client would be able to reason about the message that was receiving. So you mark up the page with RDF XML. RDF means Resource Description Framework. And then there's a part of HTTP protocol, which is content negotiation, which means that the client would say, hey, give me what the content you have, but I'm able to understand RDF XML, so please give me that version. So you would have a resource. It is a web page. It will have multiple versions. Okay, so you can think today in terms of the world of APIs. If you have a web page that has an HTML version that you send to a browser, and this same web page has also a JSON version that you send to an API, to a client that is able to process this JSON and do something with it. So this was smarter in the sense that what we would send wouldn't just be JSON, would be something that would have all this meaning inside, but it required for you to duplicate, at least duplicate all the web pages you have, and then to mark up this according to certain ontologies. So the smart machine would always request the RDF version. Of course, this means that I have to mark up all the web pages, and I have to go, and if I have a site with 10,000 web pages, if I want to make this site semantic, so that it has some smartness, and that clients can come and understand the content I have there, I will have to mark up everything with this RDF XML thing, or there were other standards, or with any of those other standards. And this was not very nice. And that's why this stream was never realized. There was a lot of criticism at the time, and there was a lot of push from the W3C for this thing. And what ended up being is that this was too academic. So it was a bunch of people from W3C closed in a room deciding about what would be the ideal solution in a perfect world. And also, you have a problem there, which is I can say an ontology whatever I want, because I can define my own ontology. I can lie. I can say that, for instance, that a lion is an herbivore or is an omnivore. It's also herbs and plants. So it's also easy to trick the system. So I'm trusting you so that ontology with which you marked your content, it's reliable. And it really represents what's there. But if I'm a spammer, and if there's no mechanism to check if what's being sent really corresponds to what you say, what I say I'm sending, then I will be able to trick you. So if I have a spamming page that has content about, I don't know, selling fake watches, fake Rolex watches, I can say, oh, this is a page about Rolex collections, Rolex watches collections. And people that would be interested in Rolex watches collections would fall on this page, and instead of having a page about information about the history of Rolex, for instance, they will get a page where people are trying to sell fake Rolex watches. So it was a spammer's wet dream, in fact. So in the sense, was good that it never went ahead, because like mail that we have today, and we still have the problem with spam, and now we're trying to fight it because the protocol really trusted people. It came from the world, the academic world, from the university, and from the military. Now we have this problem with spam, and now we would have a new avenue for spammers to explore with this metadata and these ontologies. So, and I haven't even talked about other things, because they say, okay, this is a nice idea. Now that they have this ontology and I can query what's going on, maybe also I can define a way how to query that knowledge that is embedded in the ontology. So they defined a language called Sparkle. Yeah, it's like a recursive acronym. They found this very funny. It's very common also in programming world. So Sparkle, it was inspired by SQL. It's kind of SQL. It's just slightly different. I haven't used it in a long time, but you can find examples on the web how it works, and there are still some servers that have it. I think there is a version of the Wikipedia with a server somewhere, because there is a marked up version with RDF, I think, of the Wikipedia. Still, I don't know if it's still being maintained, called DBpedia, and I think that one of those versions is queryable with Sparkle. So you could query the things and make inference about it. So they had like an whole suite of things that you would bring and use to make this smartness, now that you have in your resource, be available and to be explored. So the question is, right, this didn't work, right? So it has been 10 years, and apart from some big projects and big companies like BBC, for instance, they marked up all the BBC Radio, they marked up all the CD collections they had. there isn't much other projects I know. So it was kind of a thing that was used like in government institutions, in academic institutions, but like in the real world out there of private companies, they weren't very interested in doing because it would be a huge cost, and what we would gain from it was very unsure and uncertain. So it floundered. So what about if we realize that not very later than this, I think, of the semantic web exploded in the scene was 2005. We had the smartphone revolution, right? So we had the iPhone in 2007, and the funny thing is this: the smartphone comes with a lot of sensors, right? So when you rotate your phone, it rotates the images. Why? Because it has a gyroscope. It knows exactly the orientation. It has an accelerometer, right? It knows if the phone is moving too fast or not, if you throw it or not. It has a GPS sensor, and it can do Wi-Fi location. It uses your Wi-Fi also to get the geo-IP and get your location. So sensors became cheap and abundant with this smartphone revolution. So can we do something about it that maybe can realize this dream of the semantic web in a different way? Let's see. So sensors, okay, sensors are coming up now on the internet, right? Because the sensors started with the smartphone revolution, and they are not like the web that exists has 30 years or more than 30 years, and there's a lot of content out there. So instead of going and retrofitting all the resources that are out there with the markup, RDF, XML, now that the sensors are coming online, why don't you put the sensors online, but put some metadata into it so that you can make them smart? So sensors are for machines sensing the world, right? Accelerometer measures acceleration. Gyroscope measures orientation, right? Or in angular velocity. So if sensors are something that machines use, don't have any interaction with humans, then you don't need to bring anything as complicated as an ontology, because I don't need to understand the animal kingdom, okay? I'm just measuring if this is an acceleration and what acceleration it is, what it is. It's the acceleration of a car, of a plane, of a phone. So we're coming online now. So we don't need to retrofit these resources, okay? Because this idea of the IoT, its IoT revolution is coming now, right after the trail of the smartphone revolution. So if the things are coming online now it's a good time to address this issue and not do the same mistake from the web, which has kind of an organic development, and then they try to retrofit the semantic web. So yes, that might work. So let's see how we can approach this. So now, small intermission and the part for commercial. So I work for Relayer, which is a German company, and I think that people have a misconception about IoT. They think it's about the hardware, but it's not about the hardware. So I can tell you that in the beginning we developed a product. So we work with these companies here. We work with these companies here: Cisco, Bosch, Siemens, ARM, and Freescale. So these chip manufacturers. The chip manufacturers. This is appliance, Bosch, Siemens, and this is a networking company, network equipment company. Also software, WebEx, and things like this. So in fact, the company, when it started, it was software. It was a hardware company, and I'll show you what we did. We did this. So this was the project that we launched. We launched kind of this in crowdfunding. I wasn't at the time of the company. I've been there for 2 months, a little bit more than 2 months. So this is the project they started. It was a crowdfunded project, and at the time, 3 years ago, there was no starter kit for you if you want to start to play with sensors. And the Wi-Fi chips that you had, they were really expensive, like the ones you have on laptops, Intels or things like this, or they were really crappy, and there was no middle term. So what happens with this device is that for the time it was like a very outstanding device, but today, 3 years have gone, and we are phasing out this now. We are no longer focusing on this, but we focus instead on the software, because that's where the value is. So we have the sensors. So we just use the hardware. What happens is that IoT is a new market, right? So if you go, even when you talk with a big company like Bosch, Siemens, you might think, oh, the Bosch, Siemens, they do appliances, home appliances, so they know how to do Internet of Things. In fact, they don't know, because the industrial world, they work with completely different protocols and standards that are from the 70s and 80s. For instance, buildings has a thing called BACnet, which is from the 70s, and it's very stupid the way it works. It doesn't have any smartness like Internet protocols or modern microprocessors. It's a very stupid thing. Just it comes from relays, just switching on and off relays, and then they just ported this to electronics. That's what they did. So we have, from the part of the sensors, we don't do hardware, but if you come to us and you have a problem, we can point you in the direction of hardware or help you build a prototype. But what we are interested in exploring the software stack around IoT. So getting a dashboard like this we have here, where you can add your device, I will show then how it works, and then getting the data out. Because IoT, it's not about control. People think that it's about controlling machines. It's not. Because the same way that web pages are out there and you cannot retrofit now the RDF XML on it, most machines that are out there, let's take a dishwasher. Most dishwashers are already installed and they are not IoT enabled. And even today, if you go to a store to buy one, if you want one that is IoT enabled and with fancy controls, they're really expensive. So 80% or maybe more than 80% about IoT is about the data and using this data. So IoT uses many protocols. So this is MQTT. It was initially called message queue telemetry transport. This was a IBM internal private protocol or proprietary protocol, and then they saw this IoT thing coming on the scene, and they said, "Wait, we have maybe something here, a chance to get into this train, to catch this train." And so they open sourced this thing, and now it's part of the Eclipse Foundation. And now they dropped the message queue. They just call it MQ telemetry transport. CoAP is a very recent protocol. It means Constrained Application Protocol. It's a very recent protocol, and it was standardized last year only. And the idea behind CoAP, you see this next to another. So we have HTTP, that's like for the web, basically the basis of the web and modern APIs, and we have CoAP. And the idea of CoAP was to take the same approach you have in HTTP with REST interfaces and URIs for addressing resources and apply it to the Internet of Things. Of course, the Internet of Things are small power devices. You cannot expect to have the same type of connectivity you have when you have your laptop connected to some server somewhere. So CoAP, instead of working with TCP, works with UDP. And it has some mechanisms for intermittent connections or unreliable connections to work. So it has the same principles in terms of REST interfaces, and it has also, it takes in consideration the fact that communications are reliable in small devices, and the protocol addresses those issues. It has also one thing, I won't show this, but it's just a curiosity. You can define when I access a resource. For instance, if I access a device that is sensing the environment in this room, I can access a particular URL, which tell me all the sensors that are there, like temperature, humidity, an estimate of the number of persons in the room, etc. So this is one thing that wasn't available in HTTP, and now that you did CoAP, that just extends HTTP to the Internet of Things world, they introduced it. So these protocols are modern, are open and fully standardized, and you build APIs on them. In fact, I don't think it should be called Internet of Things, it should be called Internet of APIs, because things, it's just a vague, very vague name. In fact, what you do is just explore APIs from the sensors up to the cloud, and then you use those the data from those APIs to do some analysis and to derive some interesting things that you can propose, like the example of the dishwasher, where if you have in fact, we developed a retrofit kit for Bosch Siemens, where you would put a small kit with the sensors, with a bunch of sensors inside your dishwasher, and this would send data to our cloud, and Bosch Siemens could see what's going on, what's the information being sent, and they could do kind of predictive maintenance. They would know, for instance, if there's certain vibrations coming on with a certain frequency, this means there was a failure mode for the water pump. And I don't know if they do this now, but if they don't do it now, probably should do it in the future. They would be able to tell you as a client that your dishwasher has a problem with the water pump, and replacing the water pump costs X, and buying a new machine costs X plus 2, and then it's up to you to decide. So, currently we support MQTT, HTTP, and WebSockets, and CoAP is coming later this year. So, this is what I talked about. So IoT usually is almost exclusively on hardware, and I had a table upstairs yesterday, and people come and ask me if I sold the hardware that was on the table, And I explained to him, no, we don't sell the hardware. This is a losing proposition. In fact, if you go to Kickstarter now and you see companies that do IoT, they just use Kickstarter as a way to get funding for their hardware prototypes, but they don't define themselves as an hardware company. Because if you think a project like Arduino, if you buy an original one, costs 60 euros, but now there's a better device that costs 20. It's the same kind of thing, programmable in the same way. It costs 1/3. So if you're really betting your farm on hardware, this is a losing proposition, unless you just want to work with scale. But then you don't do it in Europe, right? So it's like Apple, designed in California and manufactured in China. So hardware is just a tool. So our software, people came to me yesterday and asked me, okay, if we use our cloud, what's the pricing? It's so new, we don't have any pricing yet, but don't worry, there'll always be like a free tier. So don't worry about it. Unless you have a very huge volume of data, you can just start playing with it right away. And there are other IoT cloud offerings, like AWS, for instance. And although Amazon is a huge company with a huge name on service as a software and platform as a service, um, software as a service, sorry, and platform as a service, they are doing this thing of IoT, sort of a me too. They said, oh, we also have an IoT strategy, but if you start to play with it and you just want to have a prototype and you want to have it up and running really fast, it's really complicated. Furthermore, it requires you to install certificates on the device, and some of the devices are so small, like 128K or 64K of RAM, you cannot do this kind of thing in one of those devices. So you need like a bridge or a gateway device. Something like the Raspberry Pi would do, but that's already a Linux computer. And furthermore, it draws a lot of power. So if you have concerns about power, this is not a good thing. For instance, you cannot have a battery power supply because it would drain the batteries really fast. So you need to have some sort of charging mechanism that will make the price go up. So we also have security in mind. So if you have something that supports TLS, we have WebSockets, secure WebSockets, HTTPS, and MQTT over TLS. So, but for you to start prototyping right away, you don't need it. So I'm going to do a demo now. So we have an application here. We have an application here. So, okay. So we have an application here. This. So we have an application which is still you need to go to the login, but I cannot see here. There's a thing here. So let me try here. Okay. That's right. They've shown the login here. Okay. Okay, this is interpreted. Okay. Somehow it's interpreting this as a smartphone or a mobile device. So I will show you here the phone, my phone, and here it is. Okay, this is my phone. So I'm going to enable it here. It has a bunch of sensors, like the smartphones have sensors. You need to enable this. So acceleration and let's see if we can see it. Strangely enough, it should work. This thing should work. Let me see here. No, it's not working. Okay. Wonder why. Flashlight. No. No, so I'll close the application and open it again. Always fun with demos, always fun. So it's a beta application, so it might have issues. Furthermore, it's developed on an Android 5. And this is an Android 6, so it might be slightly different to wait. Here. Yes? No, I think it's working. At least I can try, but it's working on my computer, so I don't see any reason why it shouldn't work here. Yeah, it's working. I think it's a question of the app. Let me kill it and open it again. Smartphone, IoT for smartphone. Okay. Open it again. Okay, now it's working. Okay, so beta and Android 5. So I will show what's here later. This thing here, we'll play with it. So now it's working. I'm sorry that you cannot see. So the screen, this is being interpreting this screen as a. I'll show you here what's going on. So it's telling me the battery level, tells me where it is and where I'm at, and I'm going to send a message. Okay, and you will see. So this is using your smartphone as a IoT device. So all the sensors that are here, I'm able to play with this. It tells me the battery level, all those things. Okay, so I'm going to turn off the acceleration because it drains the battery, and I'll go back to the presentation. Okay. Okay, so this is using your smartphone as an IoT device. So bringing up the thread where we left it when I do the commercials. So we sense a physical phenomenon, and we can define meanings for this phenomenon, for that data stream, meaning temperature, meaning humidity, meaning acceleration, etc. And we can distinguish about multiple sensors. If we have multiple temperature sensors, we can distinguish between them. For instance, we had the problem that when we developed this project for Bosch Siemens, they had a fridge, and the fridge has a freezer. So it has two temperatures. It has a temperature below in the normal fridge, it has a temperature on the freezer. But we don't want to call one temperature, freezer temperature, and fridge temperature. So you can add additional fields that will define exactly, distinguish between the meanings of those things, distinguish between both temperatures, okay? Both are the temperature, but one is for the freezer and one is for the bottom part of the fridge. So all this is metadata, and I know metadata today is very popular. Everyone talks about metadata. The NSA collects metadata. So I think there's a there's an abundance or too much metadata being talked about. Okay, so let's see what we would approach this, and this is how we implemented it on our platform. And in fact, this is how the phone is the data that the phone is sending is being interpreted. So what we have here is a JSON object that defines. So this path is what I talked about this when I gave this example of the fridge. So here would have a path would be top or freezer, and will be the temperature on the freezer, and you would have bottom, and will be the temperature on the bottom of the fridge. So this is what this additional field is doing. It's distinguishing between both physical units. So and then you have the value schema. I will explain this where this comes from. So it has we say it's a number. It's just a JavaScript type number. The unit is Celsius, and it goes between -100 and 100. I just think it's insane. -100. I don't know what they are doing. Maybe liquid gas or something like this. And template is just to define one of those widgets. I'll show you. There's one widget for temperature that shows a thermometer, and it shows that we're reading a temperature. So our ontology uses this HTTP JSON schema. Okay. So JSON schema is a thing that was inspired by the XML, but without the XML, it uses JSON. And since it's JSON, it means it's JavaScript, so it means it's data, but it's also code, which is always nice to have. And it's a web-friendly format. So I'll show you now an example of this in action. So let's go here and look for temperature thermometer here. Okay. So this is what we have here. So you define this. You define that metadata there, the JSON object, and this when you set template temperature, you define this thing here. So it goes. This one just goes from 0 to 100, but you can have multiple. You can make the scale go as big as you want, bottom to the top or to the bottom, and you have the humidity. So this is for this product. This impact this template here, this widget is for the product I showed that the company started, the Wonderbard. So it has a sensor. It has 6 sensor boards, and one of the sensor boards is a temperature and humidity sensor, and that's why you have 2 things here. But that's what you can do. Once you have this metadata, then you can interpret this, okay? And if you can interpret this, then something that is going to read this information is going to be able to tell exactly what's coming on and to reason about it. And reason here means do some action. So go back to the presentation. Okay, so it's a so another thing is that we would like also to send commands. Although I said that 80% of IoT is data, just reading data, if you can send some commands to the devices that are sensing this data, it's really nice. And so since we support MQTT, and MQTT is a pub/sub protocol, so publish and subscribe, and it's not a request response protocol like HTTP or CoAP, you have to kind of hack your way into getting this request response of this command into it because it's not a natural thing for the protocol. So I think CoAP is a better protocol, in fact, because it also has a pub/sub. So there was an original standard that was just request response, like HTTP, and then they added an additional RFC, which has this pub/sub. It's called observer pattern. So how can you mock this request response pattern with MQTT? So I'm going to do that. So here it is. We have this JSON object that says commands, a name command, path led, and then we have a value schema. We know it's an integer and it only has 2 values, 0, 1. It turns on off a LED. So I can show this on the phone. Go to the phone again. I'll show you. Yeah, you can see here that this is command about turning off the LED, but I'll show it on the phone. So the phone has these 2 commands. It has a flashlight, and I'm going to enable the flashlight. Control the flashlight. It's already enabled. So if I put true, no, doesn't seem to be working. Okay. Seems I need to do something to make this work all the time. This application is really unstable. No, I have to kill it again. Let's see. No. Well, it's better. So you're not expect to work all the time. So I have to kill it again. Strangely enough, in my hotel room, everything worked, and now it doesn't work. So IoT. Okay. Okay. Now let's see if the flashlight works. Well, it worked? Okay, okay. Now let's say it's worked. Okay, so now you see I'm sending a command just turning the flashlight on and off. I will turn it off, okay? I'll drain the battery, and I can also have this play a sound. Okay. Strangely enough, you shouldn't play the sound because it's disabled. And now I have to kill it again. No, okay, it stopped. So we just this needs some tuning, this app for sure, at least in Android 6. So go back to the presentation. Okay, so we saw how it would work with commands. But you can go even further. You can add configurations. Sorry. You can add configurations. So imagine that you have like a firmware update, and you can send this firmware update over the wire or over the air to your device. So this will be a configuration. Although the phone doesn't have this, I'll show you how this is taken care of in the JSON schema. So you would do something like this, configuration, frequency. I will show you just on the dashboard an example, but you could get, for instance, sampling frequency. Okay, you would get like a sample frequency, like it says here, of a given sensor. So if I'm reading a temperature, I could say, okay, I want a temperature to be read every second or every minute. So this is kind of configuration also, or even updating the firmware also is an example of a configuration. So you have here the frequency, I'm reading the temperature, and I can say how many, this here I want 5 readings per second, per minute, sorry, 5 readings per minute, but I can change this frequency. This is configuration. So we're taking care about readings, about the data, about getting the meaning of the data. We take care about commands. We can send commands and change the way the device behaves. And we can also change the configuration. So I already show you this, the phone. So I'll show you how it works with the configuration, how it looks like on the dashboard. So we go here to temperature, thermometer. So this is what it is here. We don't see it. Go here. So it's here configuration, and here what you would change the frequency, and then you can say 200 milliseconds to 2 milliseconds, 5 to 2 to 1 reading every 2 seconds, 5 readings per minute, or 1 reading every 2 minutes. So you would change this. So back to the presentation. Okay. So if you use metadata in a judicious way, you can really have your IoT setup really smart, because whatever would be reading this data from the phone or from whatever sensor you have, if you mark it up, then you can have all your things. You can reason about this and do things about this data. So in the sense, it's a kind of a poor man's version of the semantic web. It's not as rich as the original semantic web, but it doesn't matter, because what's the actors in this thing, they are not that smart either. They're just machines, and they just need minimal context information. And this context information is enough for them to reason about things and to do actions based on this, the way this information is marked up. So I rest my case. I will show you just a final example how it works. If you want to see all the schema, I will show you how this is. So if we go here, if we go to the phone, okay, there's the thing here, device model, okay? So this is the device model. So now you see the full picture of how this looks. So in fact, there's more things. I just show you the insights. So we have resources, you have firmware, you have commands. So you see the play sound thing is here, the flashlight, type boolean. So you have all these things here, readings, the acceleration, unit is G. So you have everything here. In fact, this is when you bring all together, this is what it looks like. So we have a schema for this, JSON schema for this, and we use this to define the meanings about the data that you're getting. I think this is one of the most interesting, if not the most interesting aspect of our dashboard that you're seeing right here. So this is a very interesting thing, because then you can make your IoT devices be smart and reason about it. So going back to the presentation. So I rest my case. I think this is an interesting approach, IoT. So we are still on time. We have the devices be smart. It's not like the web that is like, well, 30 years later they decided, oh yes, we missed something, and now we need to make something about it to make the web be smart. And I invite you to come and test our IoT platform and making it better by, or help us making it better by testing your IoT projects on it. So you have here resources. Just shoot me an email or ping me on Twitter and ask me questions. I'm here to help you, or you can ask me here. I'll be around. Okay, thank you. Questions?
Hello, thank you for your presentation. I wanted to ask, as I understand, the relayer is like a hub for devices and sensors.
Exactly.
Yeah, and what's the next step and tools to make smart decisions based on these sensors and
So right
devices?
now we are in the process of putting in place rules. So you know this site called if this then that.
Yeah.
So this is a site where you define rules, and you can say, like, you have a thermostat at home, and you say when the temperature reaches this level, like, turn on the air conditioning. So we're in the process of adding this. So if you can parse this JSON, then you can understand exactly what is being sent, and then make a better decision than just, you know, brute force things and try to get the data in bulk, and then, I don't know, do regular expressions or something like that. Here, there's really there's a meaning, there's an intrinsic meaning to it. This is what we're doing. Another thing that we'll add later is having like a data analysis. So all the data that you send is stored in Cassandra. So you can get all the data out and then do whatever you want with it. You can use our widgets, or you can develop your own. It's up to you.
Okay, and do you have right now some kind of tutorials to integrate for smart homes?
So now it's the Achilles heel of our of our company. So the documentation is bad, and I'm being completely honest about it. So most of the stuff I've shown about here, I learned it. So I've been there for 2 months. I learned it on my own about with bugging people that work on the API and on the front end and doing some reverse engineering. So right now, if you want to, we don't have tutorials. So if you want, you can ask me or go into the forum and ask questions. There's the documentation, but it's far from perfect. So the documentation was written by a person that is not technical and doesn't understand APIs. This person doesn't work in the company any longer, but it was done by this person. I mean, she did their best, but you see through that this was done by someone that doesn't understand. So just use our forum and ask questions. We're working on it. Thank you. Yep. Mm-hmm.
Yeah, I saw a configuration section on some sensors with where you can adjust the frequency. So can you
Yeah.
tell me more about how it works? Like how?
You mean this one here? This example here?
Yeah.
Okay.
Like reading temperature. So
So the
does it?
frequency here is the sampling frequency. Means what's the frequency of the reading of the temperature that you're doing? It's not a continuous reading, right? Because you don't have I mean, you could have a continuous data stream. In fact, this is a little secret. There are no limits, but please don't abuse, or we will bring the site down. Which we're working on, even putting the limits in place. So what it says is that you might not be interested in getting the temperature every second. All right, you might just be interested in having a temperature every minute or every 10 minutes, and frequency is that. You're just defining what's the sampling frequency of your data. What's the interval of time? What's the interval between temperature readings? That's just what you define. Exactly. No, the sensor is always reading. It's then the sending of the data to the cloud. It's going only to happen in this time. Okay. So the sensor is always working, but then in this case, this is from the Wunderbar. This has the sensor module that communicates with the master module that has the Wi-Fi. It sends the data to the cloud. So the connection between this and the master module, which is Bluetooth Low Energy. So the way it works, I don't know because I haven't seen the firmware, but in practical terms, what this means is even if you're reading the temperature continuously, you will only get one reading sent to the cloud every 5 per minute or every 2 minutes, one, if you go here to the maximum value, okay? So it's as the device, the physical sensor works as you want. It's just then you define some other process on top of it that say, I don't want continuous temperature, or I don't want a temperature every second, I want every 10 minutes, or every 1 minute, whatever, okay? More questions? Okay. Thank you.